So I'm going to write out here for this video as well some of those key facts, especially the three. Well, we're not there yet, so let me wait it out. Let's just take a look at this. So, all right. So here's question number one. Question number one from the homework. And so what we want to do for question number one from the homework here is try to match these up. Here, actually, what looks like you guys are still copying down. Let me. So it'll be a good time for me to write out. So the first, I'm just going to write it out so it's on the video. So the x-axis or polar axis symmetry test. What is it? Replace. Whoop, that's not how you spell replace. Replace theta with negative theta. Simplify. If the same as original, if it's the same as the original, then it's yes. Otherwise, here's the part I did not write on the board. Otherwise, it's maybe. Isn't that weird? Basically, these tests, rather than being yes or no, if you pass them, it's a yes. If you fail them, it's a no. It's actually not that way. These tests are, if you pass them, it's a yes. If you fail them, it's a maybe. That's weird, huh? It's like medically, how they have medical tests, and you can get a false positive or false negative. You know about that kind of stuff? They can say you have this condition or don't have it, but they can be wrong. They know there's always a percentage chance that they're wrong based upon things. I don't know if you've heard about that before. False positives, false negatives. Well, these things can give us a false negative. They don't have any false positives. If they say yes, it's a yes. If they pass the test, they got the symmetry. But if you fail the test, it doesn't mean you don't have the symmetry. You might still have it. You probably don't, but you might still have it. So we'll say maybe. So we're going to say yes or maybe. That's what we're going to say. It's going to be the conclusion to all these questions. So there's the first one. Do you notice how the three of them are always replacing something? So this one's theta with negative. This first one's theta with negative theta. And what that looks like, x-axis symmetry, that would be, here's the x-axis. That would mean the same graph above and below the x-axis. Symmetry means same. My high school English teacher, my senior year, she made us, I felt tortured at the time, she made us memorize tons of prefixes and suffixes. And she swore that would help us know a lot of words in the future. She was actually right. That's been very helpful. No, I hated it at the time. So sim, when S-Y-M is in front of any word, that means same. Sim means same. Symmetrical, symmetry. So sim means same. So when we talk about x-axis, which is called the polar axis, because we're in the polar world now, the polar axis, symmetry about the polar means you're same above and below the polar axis, the x-axis, right? The second condition was the line theta equals pi over 2. What is that line? It's this line, right? That's 90 degrees. That's pi over 2, right? Remember, this is 0 degrees. This is 90 degrees up here, straight up, right? So, in other words, they're saying the y-axis, aren't they? That's the polar way of saying the y-axis. You tracking with me? So you see how we have the way we say things in the rectangular world, x-axis, y-axis, and then the way we say things in the polar world. This is our last section. We're fully into the polar world here. So when they say symmetry about the line theta equals pi over 2 is straight out, 90 degrees. That's the y-axis. They're basically saying, does it look the same on the right and the left of the y-axis? That's y-axis symmetry, or theta equals pi over 2 line symmetry. How do you test that? You replace both r with negative r and theta with negative theta. That's step 1. Step 2, you simplify. And step 3, if it's the same as the original, right? Sim means same, huh? If you do these replacements and the equation comes out looking the same means it's symmetrical. It's got that symmetry. If same as original, then yes, it has that symmetry. Otherwise, maybe not. So back over here, replace, simplify, compare. Replace, simplify, compare. That's how we're going to always do these symmetry ones. And then finally, step 3, the last symmetry test. I gave it to you for the pole. The pole is the origin. They just call it the pole, like the North Pole or something. It's the origin of the globe, whatever. Just making stuff up now. So the pole, that's the origin. And how do you know if you have polar symmetry? You replace, and in this case it's R with negative R. Step 2, simplify. Like always. Step 3, compare if it's the same, that's symmetry, if the same as the original, then yes, otherwise maybe. And what would that look like? That the pole, it means, it's like diagonal symmetry kind of. Through the pole, through the origin, it's the same on the other side of the origin. That's what that would end up looking like. So all these are 3 tests to help us get a look, a picture, a graph, and save some effort, right? If you know, we'll see. We'll see where the effort saving comes in. Okay. So be good with all that. And then, I probably better put these up real quick. So we have the limicons. So I'm putting up in both cases. So the limicons, we have the limicons that do that with the inner circle. We have the limicons that just do that. We have the limicons that kind of go somewhat straight and do that. Okay, and so it's all about A plus, I'll do it down here. It's all about A plus or minus B sine theta or A plus or minus B cosine theta. And this is if A over B is less than 1, if A over B equals 1, and if A over B is greater than 1. So we have the 3 limicons, and we have the roses. And the roses are all about Y equals A sine n theta, right? Yeah, A sine n theta, or Y equals A cosine n theta. If n is odd, then there's just n petals, same. If n is even, you have 2n petals, double. And so I gave the examples. What I give? A sine 2 theta. So 2 theta. So see how if it's even, you double it. There's going to be 4 petals, right? 1, 2, 3, 4. Whereas if it's odd, like A cosine 3 theta, that's one I did too. It's odd, it's going to be 3 petals. So 1, 2, 3. So good enough. So that's the plan. All right, let's go back and answer.
Is there a difference between the sine and
Yeah, we'll talk about that as we go. There'll be more detail. All right, so question number 1 is a mixer matcher. So we're just wanting to say, hey, got all those functions, got all those pictures. Who goes with whom? Who matches with whom? So we got to match those up. Question number, it's the only one like it. The rest of them are going to be different. This is the only mixer matcher. So it's like, let's take the first one. Let's take R equals 2. So, I didn't give you the basic. Let me give you the basic. Give you all that fancy stuff. Here, let me just give you one more basic fact. If you simply have like A sine theta, you know what that's going to do? That's going to be a circle like this if it's positive. If it's negative, it's going to be a circle like that. Versus down here, if you have A, like a positive A cosine theta, that's going to be a circle over here. And if you have negative A cosine theta, that'll be a circle on the left. It's a bad circle. But there we go. There's a lot of information. You put all that in your 3x5 card. Jose, you think it'll fit? So, you have to write small and C sharply. You're not going to need it all. You'll see as we go. But anyway, so let me say this in a way that'll help you, and I think you probably already figured it out. What would help you looking at that? Just remember that.
X and Y.
X and Y. Yeah. What have we said about sine and cosine all along from day 1? Here we're on almost last day. What is sine always? X or Y?
Y.
Sine is always up, down. It's always been Y, hasn't it? And sure enough, there's sine. It's up and down, isn't it? Whereas cosine is on the x-axis, either right or left. Positive x-axis, negative x-axis. Sine, positive y-axis, negative y-axis. Makes total sense, doesn't it? It's what we've seen all along. So those are the basics. Those are just the basic pictures and shapes. And then we have the fancy roses. How do you recognize the roses? Well, with the roses, they always have something multiplied by the angle, like a 2 theta or a 3 theta. That makes the extra petals come into play. If it's odd, you get exactly that number of petals. 3, you get 3 petals. 5, you get 5 petals. 7, you get 7 petals. If it's even, like 2 theta, you get 4. 4 theta, you get 8. 10 theta, you get 20 petals. You get the idea, right? And then the limicons, how are these equations, how are you going to recognize these? How are these different than the rose equations, right here, or these basic equations? They got adding, subtracting another number. See how the basic equations just have a number times sign or a number times cosine. Nothing added. You might go, what about that plus sign? Yeah, but there's no number. There's no like 7 over there or any other number, right? There's just the one number, positive or negative, multiplied by sine or cosine. That makes a basic circle. Above, below, right, or left. And these as well, they just have one number multiplied. Whoops, I'm erasing it. One number multiplied by sine or cosine, and then a number multiplied by the theta. That makes the petals, the roses. But with the limicons, they're different because they have a second number. They have 2 numbers, one number multiplied and another number added or subtracted next to the sine or cosine. Those 2 numbers work together. Their ratio of those 2 numbers tells you what kind of limicon it's going to be. An inner loop, if the ratio is less than 1. A dimple, if it's equal to 1. And like straight, if it's greater than 1. All right, are we ready for all that? And then we have these 3 tests. Just as easy as that. All right, here we go. It actually will be easy. I'm just joking. It seems intimidating right now. Here we go. So first one, r equals 2 sine theta. What do you think? What do you think that very first one is going to be? We have these 6 graphs. 1, 2, 3. Let's just, so we can all, 1, 2, 3, 4, 5, 6. Which one of those do you think it is? First off, is this one like a?
I think it's 6.
Oh, here, why don't we? I don't know why they wrote them up there and then wrote them down here again. It's kind of confusing.
You're supposed to drag and drop.
Yeah, you're supposed to drag and drop. Well, let's just start here, since those are the ones we actually drag and drop. I'm going to start down there. So that one they put. Yeah, we'll get there. Let's start here. So I changed my mind. Let's start with this one. 3 plus 3 sine theta. So which of the is that a rose, a limicon, or a basic? It's a limicon because it's got a number added. It's got 2 numbers, in other words, there. Right? You guys with me? So, in other words, one more time. The limicons have 2 numbers. The roses have the double or triple with the theta. And then the basic don't have either of those. They just have basic. A plain theta and 1 number in the front. Okay, so getting back to it. So this is a limicon. And you're supposed to take 3 over 3, which is 1. So what is the limicon when the ratio exactly equals 1? It's a dimple. So in other words, it's going to be a dimple. Which one is a dimple?
It's going to be 1 or 4.
Yeah, and since it's sine,
So
do you think it's going to be on the y-axis or the x-axis?
why?
Yeah, sine's going to be on the y-axis. There's going to be dimple on the y-axis. Now, this is a dimple on the y. That's a dimple on the y. This is dimple on the x. That's got to be a cosine.
That's a circle.
Oh, that's a circle. It's going to be a circle. Yeah, there's no dimple there, huh? That's a circle. So, thank you. And, yeah, these 2 over here are sines, aren't they? I'm sorry. This one's cosine. That one's sine, but that's a circle. Number 6 is a circle. So it's either 1 or 4. Which one do you think it is?
4.
Because it's positive, it's got to be number 4, doesn't it? Does that make sense? Going up? And that's what it is. So we grab it and go, boom. That goes to there. Okay, let's do the next one. So the next one is 2 sine theta. What's that?
It's a circle.
Yeah, that's a basic circle, right? Basic circle. Basic circle, right? It doesn't have a second number added. It doesn't have anything multiplied by the theta. Right? Multiply by the theta, you're a rose. Put another number added, you're a limicon. That's a basic circle. Is it going to be a circle on the y-axis or x-axis? Y, because it's sine. So which one is it? 1, 2, 3, 4, 5, or 6? 6 is right. Are we making sense out of this so far? How we doing? Is this making good sense? Okay, number 3. R equals 4 sine 3 theta. What's that going to be? Yeah, it's got the 3 theta. So that always makes it a rose.
And it's an odd rose.
Odd rose, so how many petals?
3.
Going to be 3. We see it down there. There it is. All right, we're rolling these out. Next one. 3 minus 3 sine theta. Is that basic, limicon, or rose? That's a limicon. Got the 2 numbers. The ratio is 1, 3 over 3. Doesn't matter about the sign. Don't worry about the negative, positive, whatever. Just the absolute value of the ratio is 1. So that means it's a dimple. It's negative. So it's going to be, isn't it number 1?
Yeah.
Number 1 there, right? Because it's going down on the y-axis, dimpled. There it is. Good. To number 5 we go. 2 sine 2 theta. What's that?
Rose.
A rose with how many petals?
4.
4, because even numbers always double the number of petals. There we go. And the last one's got to be the last one. The last one, right here. 2 cosine theta. Is that a limicon, rose, or basic? Basic. There's nothing multiplied by the theta. There's no number added. Stretch is basic. Cosine's going to be a circle. X-axis or Y? X. That's what we have right there. X-axis circle. Pretty straight ahead, right? Now we're gonna graph these by hand, and well, we're gonna like 1 by hand just to see once and for all how they come about. But for now, there we go. Good. So if you have these facts on your 3x5 card or some semblance thereof, you'll be fine on tomorrow's test for these. Questions on that one? Okay. So R equals 5 cos theta. So now we're going to go through the tests. So we're on question number 2 now. Now there's no more mixing and matching. It's go through the 3 different tests, and you can see the answers are already there. Yes, maybe, and maybe again. May or may not be. It's a maybe. So it's yes, maybe, maybe. Let's see how we got those answers. So number 2, R equals 5 cos theta. All right, so first test. First test is test number 1, part A. Test, and it's polar axis, which is basically the x-axis. So how do we do it? Step 1, replace theta with negative theta. Okay, so let's take that equation right here, and let's replace theta with negative theta. R equals 5 cosine negative theta. We good so far? I just took it and stuck negative theta in for theta. Step 2. What are you supposed to do second? Simplify. Simplify. So let's take it and simplify. That negative, so what did we review? Negative inside of a cosine. Finals in 2 days. We'll be tested on even odd functions. It's one of the many things we've learned.
It goes positive.
Yeah, it becomes positive. It's like x squared. It's like plugging a negative into x squared. Cosine's an even function. It just vanishes, doesn't it? So when you simplify, it just becomes positive, or not. You can just skip it completely. Just goes back to regular. The negative vanishes, becomes positive, right? That's what cosine is. Sine or tangent, the negative goes out to the front. But cosine, it vanishes because cosine's an even function. Okay, so the step 3, is this, or are those the same?
Yes.
Is this and this the same? Right, we're comparing the simplified, not those two. What am I doing? I'm getting totally confused. Is this the same as the original, huh? Same. What's the original? R equals 5 cosine. Is this the same as the original? Absolutely. Absolutely the same. So that's a big yes. Yes, it has that kind of symmetry. That polar axis, x-axis symmetry. So that's what we learned. This graph, when we go to the picture, we can expect it'll look the same above and below the x-axis. The polar axis, they're calling that. It's got polar axis symmetry. Everybody good with that? See how I conducted that test? I just put in negative theta and simplified, which means I applied the rule that negatives in a cosine vanish. And it came out looking the same as the original, didn't it? So it's got that symmetry means same, all right? Test number 2. So the second, so we're still dealing with r equals, what is it? 5 cos theta. Test number 2 is y-axis or line. Theta is pi over 2. What do? Plug in negative r and negative theta, both, huh? So that's step A. Plug them both in there. So we're going to get negative r and negative theta. Good so far? So I took the original and I plugged in negative r and negative theta, both. Second part, simplify. So you plug in, then you clean it up. You follow those rules. What can I do with the negative and a cosine? Again, it vanishes, right? Cosine's even function. So this negative will vanish. It'll be 5 cosine of regular. But the negative on the r can't vanish, right? There's no reason I can make that negative vanish. The negative just stays on the r. It's not going anywhere. So the question is it the same?
No.
Is this the same as the original? Is the simplified the same? No. So, does it have this symmetry?
Maybe.
Maybe, yeah. It's a maybe. It's not a no, because we can get a false negative. The test came out negative. What does it mean? Probably not. But it might. We'll see on number 7, the last one we do today. Then it'll say maybe, but it'll end up having it. No. And why? Well, because things can sneak in the back door by backfires. Remember how we talked about yesterday how the cannon can backfire? We'll see it when we graph today. And so what it does is it fails the test, but it actually has the symmetry by backfire. So we'll see. The test doesn't really measure the backfire. All right, so on to test 3. So we've done 2 tests so far. First one was a yes. Second one was a maybe. Now on for test number 3.
Wait, why is it just straight up not no?
Why is it just straight up what?
Not no, the answer.
Because it could be.
Because so that's what I'm saying about the maybe. This is just the same reason when you go to the doctor and they test you and they go, you do not have hepatitis. Really what they mean is you probably don't have hepatitis. There can be a false negative on that test. It has limitations. That's just the reality of it. And that's the reality of this math test right here. This can tell you it didn't pass the test, but you might still have that symmetry. So all we can say is maybe.
So is the answer never a solid no?
You see, yeah, don't ever say no
Yeah, so
on these.
So okay.
Is that making sense? The third one, r equals 5 cos? 5 cos. So the third test, what is it? Pole, origin. We're seeing if it's symmetric with respect to the origin. What do you do for that one? Plug in negative r, just the negative r. So notice we plugged in negative theta 1 test, negative r for this test, and both those for the middle test, didn't we? That's how the tests work. So plug in negative r. What's going to happen? Negative r is 5 cos theta. So this is A, and then B, simplify. Okay, I'm supposed to take that thing and simplify it. There's nothing to do. You can't simplify that. It's as simple as it gets already. There's nothing to do there, right? Because if we don't have a negative in for theta, those are really our only simplification rules. So there's nothing to do. So, okay, how does this compare to the original? Are they the C says, are they the same? Step C, are they the same? No. No, this one has a negative, that one doesn't. Not the same. No, they're not the same. So what does that mean? Maybe. Probably not, but maybe. Is this good? How are we doing?
Because it's hard to prove it, that it's a maybe.
It's because it's not definite. Yeah, we'll see number 7 today, where it actually fails the test but has the symmetry. And we can look at why it does that. Yeah. Do you see, I don't like to just get, well, yeah, too early. Let me why are these tests, right, let's do that later. We better do. So it was r equals 5 cosine theta. So which one is the right graph? 5 cosine theta. Yeah, everybody see it's B? Because that's a circle, right? This is the simple kind. It doesn't have it's not a limicon, doesn't have another number added or subtracted, so it's not the inner loop kind. It's not a rows, doesn't have a 2 times theta, 3 times theta, anything like that. It's the simple kind, it's a circle. But is it right, left, up, or down? It's right, because cosine, it's a positive cosine, so it's going to be in the positive x-axis. Good there? Cosine's always x, right, left. Sine's always up, down, y. So there it is. Notice it does have symmetry. See how above and below the x-axis, that graph is the same? The part above the x-axis is the same as the part below the x-axis, huh? It's symmetrical above and below the x-axis, which is what our test showed. The first test, it said yes, it is symmetrical. See how it is not symmetrical on the two sides. The whole thing is only on one side of the y-axis. It doesn't have y-axis or theta equals pi over 2, 90 degrees axis symmetry, does it? And it doesn't have origin. It's not diagonally the same. So it's true to what we saw from the symmetry tests. Good? Questions? Number 4 here. You have, I'll just put it on the first screen. 4r equals 1 minus 2 cos theta, right? 1 minus 2 cos theta, yeah. All right, so try that out. The 3 tests. Let me let you go ahead and do it. So on your own paper there, do those 3 tests. Find out yes, no, maybe so. Well, it's not going to be no. It's either yes or maybe for each of those 3. 24?
Yeah, it's one of those cafe stuff.
Well,
There's a lot of crazy algebra.
okay. Yeah. Sounds good. It should be out there on YouTube though too, because it's from one of the earlier practice exams. And I put a key to where to find it.
Yes, there's I was hoping couldn't find it.
Huh? Maybe it wasn't actually out there. Right.
But it was on one of the exams, like exam 3.
Like the exact question?
Yeah.
Huh? Well, okay. All right, see you, Wendy. All right, how we doing? So let's go through the 3 tests. So first test number 1, what is it? Polar axis, x-axis. What do? Plug in negative theta. So I take that equation, I go, okay, r equals 1 minus 2 cosine negative theta. B, simplify. How do you simplify that? What happens with that negative theta? Poof, it's gone. Right? Anytime you're in a cosine, it just becomes positive, regular. Step C, compare. Right, or same, is it the same? That's the comparison question. Is it the same? How does this, the simplified, compare to the original? Are they the same or not? Yeah, for sure. They're the same. So this one's a yes. It's got the x-axis, polar axis symmetry, doesn't it? So the first one's yes. The other two are both no. Are you getting no for the other two? They're both no. Let's go see it. Or both maybe. Yeah, both maybe, yeah. The tests are no, so the result is maybe. Yeah. So I'll try. So it's r equals 1 minus 2 cos theta. And I'm going to do test number 2. Test number 2 is line theta is pi over 2. So we plug in negative r and negative theta both. So what do we get? Negative r is 1 minus 2 cosine negative theta. Good to there? Right? And then B, you're supposed to simplify. Now, how do I simplify? Well, you know, the negative, again, one more time, goes away. And then step C, is it the same? Is what the same? This and the original. Are they the same? Is this one the same as the original one? No. This one has a negative r, that one has a regular r. No. No, they're not the same. So that means it maybe has that symmetry. Probably not, but maybe. Right? Number 2 is a maybe. It's getting easy, repetitive. Easiest thing we've done in this chapter so far. Okay. Questions on that one? I'm going to do number 3. Test number 3. We okay with test number 2? Test number, so r equals, what was it? 1 minus 2 cos theta. And everybody got that copy down there? Is that okay? And test number 3, it's the pole, the origin. How do we test the origin? Plug in negative r. What do you get when you plug in negative r? Well, you get a negative r. I mean, it's just kind of silly, huh? There's that, and then B, you try to simplify, but there's nothing to do. You can't simplify. The only thing we can simplify is negatives put in for theta. There's nothing to simplify. Just leave it as it is. No way to clean it up. And then step C always asks you, is it the same? Is the simplified one the same as the original? No. Not the same. Not. So it's another maybe, isn't it? So it was a yes, maybe, maybe, just like last time. Yes, maybe, maybe, huh? We good with those 3 tests? Shall we look at the final answer as far as the graph now? So r equals 1 minus 2 cos. Okay, so which of those is going to be? It is a limicon, but they're all limicons, right? It's a limicon because it has a number added and subtracted in front. Now, when it comes to the limicon, how you know which one it is you're supposed to take the A over the B, the 1 over the 2. The negative doesn't matter. 1 over the 2. I mean, as far as the ratio. So 1 over 2, the A over B ratio is 1 over 2. Remember what we're supposed to compare to? We're supposed to say, hey, is that A over B ratio less than 1, equal to 1, or greater than 1, right? We go back here as well. Remember for limicons, where is it? Oh, limicon. There it is. Right, so for the limicons, we're supposed to test the A over B ratio. If it's less than 1, it has an inner loop. If it's equal to 1, it has a dimple. And if it's greater than 1, it has a straight, this is a dimple here, has a straight back. So what's our case? That's less than 1. Half is less than 1. So what does that mean it has? Inner loop. Of course, they all have an inner loop. So, yeah, it's got an inner loop. That means inner loop. Now we just have to think about sine and cosine. This is cosine. So what do you think about cosine? Cosine going right or left? Huh? Because cosine's x. Sine's up, down. Cosine's right, left. Is this one right or left?
Left.
Yeah, because of the negative, it's going to be left. If that was a positive in the middle, then it would be to the right, it'd be A. Does everybody see that? See how this limit con is left of the origin? Does everybody see that? And negative cosine is right, left, negative, left. How are we doing? It's making good sense? Anything I can say to help? Okay, so here we go. So r equals 9 sine 5 theta. 9 sine 5 theta. Go through the three tests. This will be a little different. Let's do this one. So number 6, r equals 9 sine 5 theta. Okay, so first test, test number 1, what's it called? Polar axis. Polar axis test, part A, and we plug in negative theta. Can you see what's going to happen when you plug in negative theta?
Yeah, it's going to stay negative.
Yeah, so when you take it and you plug in the theta, you get r equals 9 sine of negative 5 theta, huh? If that bugs you, could plug it in like this. It's 5 times negative theta, which I just know that's negative 5 theta. Right? Good to there? I plugged in negative theta in the theta spot. Right here where theta goes, it became negative theta, huh? I replaced theta with a plugged in negative theta. That's what they tell me to do. And B, simplify. Simplify. How do you what's the legal algebra law here for simplifying, trig law for simplifying sine? What's the rule for sine when you got a negative inside a sine?
You put it on the outside.
It comes to the outside. Negative 9 sine 5 theta, right? Negatives inside tangent or sine or tangent, those are odd functions, like putting a negative in an odd power, x to the first, x to the third. The whole thing's just negative, right? And then step 3, what's step 3 about? Compare. Is it the same? Is the new one the same as the original one? No. This one has a negative sign. The original didn't have that. No, it's not the same, which means maybe. So the first test came out maybe. The other 2 times it came out yes. So the first test came out maybe. Do the second test. You already do it, some of you? What's the second test come out?
Yes.
Second test comes out yes this time. So do the second test, see if you can see that yes. The second one is a green light yes. So the second test, which is the line theta is pi over 2. What do? We plug in both negative r and negative theta, don't we? Oops, kind of scribbly there. So plug in negative r and negative theta. What do you get? Well, you get negative r equals 9 sine 5 negative theta, huh? Okay, now that's A. B is simplify. So when we simplify that, having plugged in negative r and negative theta, negatives inside of a sine, as we know, come to the front. Comes negative r is negative sine 5 theta. Good so far? Right? Negatives in a sine or tangent, odd function, come to the front. Now, Can we simplify that further? What do you do when you have two negatives? Multiply or divide both sides by -1, huh? I can just say, look, I don't need to leave those. Let's just divide both sides with cancel, cancel. R equals 9 sine 5 theta. Step number, or letter C, compare, or say, is it the same? Is this final simplified the same as the original? Yeah, it is. So this is the first time we've had a yes, an affirmative on test number 2. This one is going to have y-axis symmetry. It's going to be the same on the right and the left of the y-axis, isn't it? It makes sense. It's a sine graph, so it'll be up or down the y-axis. It's going to have y-axis symmetry. Of course, it's sine. And then the third test is going to be another maybe. Did you do the third test already? It's going to be another maybe. Test number 3. R equals 9 sine 5 theta. Test number 3. And that's the pole, or the origin, like the North Pole. And we, part A, what do? Plug in negative R. So we get negative R is 9 sine 5 theta. B, simplify. How do you simplify that? There's nothing you can do. There's nothing to simplify. There's no negatives in there with the theta in the sign that I can take out. And there's just a negative on what's one negative, not two negatives, so I can't get rid of the negatives. There's nothing to do. So, is it the same? Is this the same? No, it's not the same, which means it's a maybe. All right, we did the 3 tests. We did all 3 tests. It was maybe, yes, maybe, wasn't it? Which one is it? 5 theta. So we're talking about 9 sine 5 theta. Odd means 5 petals, doesn't it? It's a rose with 5 petals.
I thought it was double, wasn't it?
That's for even. So if you have an even number in here, like 2, 4, 6, or 8, you double it for the number of petals. If you have odd, it's just the same as the odd number.
So 8 would be 16?
Yeah, if it was 8, it'd be 16. So that's what's on the board. 4 becomes 8. 3 stays 3. 2 becomes 4. Even doubles, odd stays the same. Good. One more. See how easy this homework is? It's your favorite section. How we'd ease. I think this one's going to fail all 3 tests. It's going to be maybe, maybe, maybe. But it's going to turn out to actually, when we go to the actual graph, it's going to have one of the symmetries. And we're going to actually see it. We're going to do it by hand. Probably you can already spot it. But let's go through the tests. So this is the last one. We'll do a thorough job. We'll be done with this. We'll take our break. We'll come back and we'll start reviewing for the final. This is the end of the course. Our last new problem. So number 7. R equals 2 minus 4 sine theta. 2 minus 4 sine theta. All right, 2 minus 4 sine theta. Let's go through the test. So here we go again. Test number 1. What is it? X-axis. Seems like a waste of time. It's going to be no on all 3. Or they call it the polar axis. It's going to be, or not no. All tests are going to be no. It's going to be maybe, maybe, maybe. So, A, plug in negative theta. Plug in negative theta. What do you get? You get R equals 2 minus 4 sine negative theta. B. Simplify. Now, how can I simplify that?
Or the negative in front of the 2.
Yeah. Well, where's it go? So that, remember, this is one separate term, and this is a second separate term. They're separate, aren't they? So this negative is going to go right there to the front of his term. So it'll become 2 plus, right? The negative 4 sine negative theta, the negative comes to the front of that term. Right? Don't get confused with that 2. He doesn't touch the 2. The 2 is a separate term. Right? Everybody with me on that? Everybody see what's happening there? So whenever a negative comes out of sine or tangent, it goes to the front of that term. Right? Why? Well, because that 2, that's just a positive 2. You could add it, you could put it at the back, plus 2. That's just a separate, totally distinct term. So don't confuse it with the sine term. Everybody good there? So it becomes this. So the question is that the same? Meaning, is this the same as the original? Are these guys the same? No. It's got different signs in the middle. It's not the same, so it's a maybe. Everybody with me? Yeah,
So
in line.
how did you know that it was going to fail all 3 tests? Is there...
I did it about 4 hours ago.
Oh, okay. I thought there was like something that you saw there, but okay.
Now. Good there? See if you just do all your homework twice. You'll have it as good as I do. All right. Number 1. There's number 1. All right. Let's go to the next one. So that's number 1. So test number 2. R equals 2 minus 4 sine theta. So test number 2, which is also going to be a maybe. It's line theta equals pi over 2. We replace them both, don't we? So replace negative, or plug in. I guess we'd plug in, whatever you want to call it. Replace or plug in. Plug in negative r and negative theta. So take that thing and plug them both in. So I get negative r is 2 minus 4 sine negative theta. So 2 negatives. Plugged in. B. Simplify. How do you simplify? Well, negatives inside a sign come to the front of that sign. So we get negative r. There's still a negative on the r there. 2 plus 4 sine theta. And then step C. Is it the same? Is this the same? Are these guys the same? Is it the same as the original? No. Yeah, Ani.
How come we're not dividing the...
Yeah, let's do it. I just know it's not going to work, but if you're not sure, let's do it. I should probably be doing it because I just look at it and I can see what's going to happen. I guess I kind of assume you all can, but maybe not. Let's do it. All right, so suppose you said, well, I'm going to, you got a negative, Mr. and you did that before. Yeah, I only did it because I knew it was going to work. Let me show you. So if we divide by negative 1, now, what's the legal law? That was kind of a repetitive statement. What's the law? What's the math law here? Can I just divide that guy?
No, you have to divide all.
Yeah, equal treatment. No favoritism here, right? When two things are equal, treat them all the same. If they're equal before, you treat them all the same, they'll be equal afterwards, right? So I divide them all by negative 1. That'll make this positive r, which is good. That matches this. But see, that'll make that negative 2 and minus 4 sine theta. It'll change all the signs. Now, does this match the original? It still doesn't match. Neither version matches, right? You ain't never. That's bad language. You are not ever going to make it match. It's impossible with legal steps to make it match. It's not the same as the original, no matter what you did. You see that? No matter what you do legally. Right? See how you compare it to the original? Now that's a 2, that's a negative 2. Before this was a negative r, there's a positive r. There's always going to be some sign different. So that's why I didn't bother to do it before. I just knew that was going to happen. So it's a no, which means it's a maybe. Right? And we got to do one more, which is going to be a no and a maybe. So step 3. So we got r equals, what was it? 2 minus 4 sine theta. 2 minus 4 sine theta. test number 3, which is pole or origin. We're going to place A, plug in negative r. So you just take this equation, you just plug in negative r. So negative r is 2 minus 4 sine theta. Good. B, simplify. So simplify. Now, how do you simplify that? You could try to get rid of that negative if you want. It's just not going to work. If you want to divide through by -1, you could. I just don't bother because I know it's going nowhere fast. Because these two will make -2, and these guys will make positive. Right? And then you want to compare. This is a theta here. And then step C. Is it the same? Is this the same? Are these guys the same? No way. That's got a regular 2. That's got a -2. It's not the same, which means, again, it's maybe. So what was all that testing for? Well, we were able to conclude maybe, maybe, and maybe. Right? That was the result of all that testing. Feels that way sometimes when you go to the doctor, huh? So maybe, maybe, and maybe. Maybe, maybe, and maybe. So, all right, now what are we going to do? Let's graph this thing. Now, I know you already know the rules. You could probably pick out the graph from the multiple choice. But I want to actually do one. You got that polar paper? We got 10 minutes for our break. Let's actually see. Turns out this one is going to have some symmetry. Anybody know what kind of symmetry this thing's going to have? Sine? What do you think sine's going to have? X-axis, y-axis, or origin? Sine? Y-axis. Sine is y. It's going to actually have y-axis, even though the y-axis test, which is this one, this is the pi over 2, that's the y-axis, said maybe, it's going to be a yes. It just didn't show up on the test. We'll see it. All right, so let's do it. Now, the way I'm going to do it, you guys have, so is this coming out in the calculator? Did everybody see that? So I plugged in 0 degrees, I got 2. Right here, plugged in 0 degrees, got 2. Plugged in 15 degrees, got 0.96 on my calculator. Let's go back. So you aim the cannon at 0 degrees and you get, oops, come on. So you aim the cannon at 0 degrees and it goes out 2. Aim the cannon at 15 degrees, it goes out just below 1. See it coming back in, right? See the movement? Like that? Connect the dots. It's an arcing. It's not a straight line. Remember this, the cannon is rotating. Can you picture the cannon pivoting? Right? The cannon is rotating. So it's gonna move out smooth arcs, not straight lines. So now let's now do 30 degrees. We already did that 0, huh? 0, so 30 degrees 0. So if you're aiming at 30, it's come all the way back into 0. Look at that. See what it did? When I aimed at 30 degrees, the cannonball went nowhere. Right? Just sat there right in the cannon. Is this making sense, these dots? And I'm just tracing from dot to dot to dot as the cannon rotates. Let's keep going. Let's go up to 45. Aim at 45. R equals 2 minus 4 sine 45. Negative 0.8. Good enough. Negative 0.8. Y'all getting that? Now, what's a negative R mean? Backfire. Right? You aim the cannon and boom. That happens in history, right? They didn't bolt those things down very good. They would kill the cannon shooter. They'd come back, right? So the cannonball backfires 0.8 when you're aimed at 45 degrees. So coming back here, you're aiming at 45 degrees, 45, and it backfires just under 1, right? 0.8, just call it under 1. Where's that? Straight backfire, under 1. It's about right there. Which, remember, it's a smooth arc. So it goes like this, doesn't it? Everybody see the movement that just happened? I was aimed at 45 and it backfired almost 1. We seeing it? Let's keep going. 60 degrees. R equals 2 minus 4 sine 60. I'm getting negative 1.5 basically. 4, 6, whatever. Good enough. Negative 1.5. Backfire 1.5 when aimed at 60 degrees. A backfire 1.5. Y'all getting that? So aimed at 60, aimed up here, backfires 1.5 to here. So it moved to there. Y'all seeing that? See how I find the backfire? See how I find what's backwards? If I'm aimed at 60, that's 2 marks off of straight up. So backwards, 2 marks off of straight down. It's on this line, isn't it? It's on the what? 240. Everybody see how I'm coming up with that? That's a backfire that's backwards from the 60. It's about 1.5. Let's keep going. Now, what's our next angle? 75. Let's go to 75. R equals 2 minus 4 sine 75. There'll only be, these take a little bit of time, don't they? There'll only be 8 of these on the next exam. No, I'm just kidding. You probably won't need to do these by hand if you just have this table information. Negative 1.9, it's basically negative 2, huh? Negative 1.9, basically negative 2. Let's go back to the graph. 75, negative 2. Right there, it backfires 2. See what it's doing? It's looping backwards, isn't it? See that looping backwards? Let's go to 90. We're getting close. Let's go to 90 degrees now. R equals 2 minus 4 sine 90. Is that negative? Yeah, that's negative 2 straight in the money, huh? So negative 2. So, boom, right there. So when you're aimed straight up at 90, it backfires 2. Everybody track me with that? When you're aiming straight up at 90, it backfires exactly 2. Straight down 2, huh? It's a backfire of 2, straight down 2. Everybody seeing that? See the graph we have so far? It's a little tedious, isn't it? At this point, I'm getting a little weary of it. If we keep going, it's going to happen. Is it going to make an inner loop? What is this? This is a limicon, right? It's going to make an inner loop. Well, here I'm going to do some more. I'm going to have to kind of speed up the process. So I'm at 90. I'm going to start skipping around a little bit, if that's okay. I'm going to go 120, 150, 180. I'm just going to go boom, boom, boom. Do a whole next quadrant. That's okay. So I've got to do a new page here. Theta R equals, what is it? 2 minus 4 sine theta. 2 minus 4 sine theta. And I'm gonna skip to what I say, 120. 120 degrees. 2 minus 4 sine 120. I'm getting negative 1.5 on that. So that means 120, negative 1.5. So if you're aimed at 120 now, if you're aimed at 120, you backfire, what did it say? Backfire 1.5. So you go backwards 1.5. So I go back 1 to there. There's 1.5. So see how I'm coming in now? I'm going to make my little inner loop thing here, I think. 120, let's go to 150. I'm going to take aim at 150 next. So 150. Get 2 minus 4 sine 150, I'm getting 0. 0. So 0 is aimed this way, boom. So it closed back in. Oh yeah, there it is. It closed back into 0. There's the inner loop. We just did the inner loop of the limicon. It was a 0. Came back to the origin. Let's aim at 180. Track with me. It's smoothly. It's just cranking out these dots, dot, 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 like that, right? See the smooth motion of it? So it's all rounded. So let's do the 180. So 180. 2 minus 4 sine 180. That's 2. Because sine 180 is 0, so that part drops out. It's just 2. So that's 2. So when you're aimed at 180, it shoots forward. 2. Let me get these out of the way, all these arrows. These are kind of confusing the issue. So when you're aimed at 180, what's going to happen is it's going to go here, which means it went like that. Y'all see that? See what it did? Right, remember it's arcing. It's tracing, 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 and then it went to 180. It went aimed at 180, forward 2. Now, I think we're all tired of this by now. If you keep going, though, it's kind of a beautiful little process. If you keep going, it's basically going to go. In fact, what's 270? 270 is crucial. Let me just jump to 270. If you do 270, 2 minus 4 sine 270, straight down, negative 1, it's going to be 6, isn't it? Yeah, 6. So what does that mean? That's where it's going to hit. When you're aiming at 270, it's going to go down 6. 1, 2, 3, 4, 5, so right here. So what it's going to basically do is go like this and go back up like that. That's going to be the graph. 6 is going to be the furthest point, straight down. If you did more dots, you'd find dots along the way like this. Is what you would find. If you did more and more of the table, it would do that. Look at that thing. Look how it's symmetric, isn't it? Isn't it symmetric to the right and left of the y-axis? But the thing just told us maybe. Remember we did the test, the middle test? That one is symmetric to the right and the left. It is. How did it do it? It did it by a lot of backfires, didn't it? So that's why the test wasn't sure. There it is. Now, we already knew it was a limicon like that. Right? We didn't need to do all this. I want you to see, though, where this is all coming from. That is a limicon. Remember how you test a limicon? A over B. A over B is 2 over 4, is a half, is less than 1. So that means it has an inner loop. It's a sine. So sine's on the y-axis. It's a negative sign, in fact. So we're not surprised. Negative sign, it's down on the y-axis, isn't it? And there we go. Are we good with that? Question.